Hello, my name's Mike M0MSN, and as some of you are aware, playing with antenna is sometimes quite a dangerous thing to do. What I will say is that whilst building this magnetic loop, I can only stress to the highest degree that it is dangerous. You're dealing with some very, very high voltage, so please abide by the rules. Okay, so she's back at home, and let me just run through some of the alterations that have been made since the other video. You may have noticed at the end of the previous video that you saw this particular rod and pulley system. This was changed. This is actually some cupboard, what do you call them? I don't know, clamps, I suppose, for the shelves. So what we're going to do is we're going to buy a pulley and motor system to fit here. Anyway, but today we need to put our SO239 on the drive plate here and build our mini loop that will go around here. Okay. Now, a mini loop needs to be made from coax and is 1/5 of the circumference in length of the main loop, or 20%. So that's what we need to do today. Something tells me that I have a slightly flat battery here. Okay, so we have an octagon, and we know that each side is 500 millimeters to the center. And so on. So we've got 8 of those. So that's 4 meters, right? Or 4,000 millimeters, which is the circumference. And we know that the small loop at the bottom, okay, has to be 20% of our main loop. So 20% of 4 is 80 millimeters. No, 80 centimeters, 800 millimeters is 800 millimeters. So what we need to do now is cut a length of coax, which is 80 centimeters in length, and we'll plus, I don't know, 2 centimeters for the joints. Okay, so we need to get a bit of coax, about 82 centimeters in length. The only thing is, I'm not sure, because we've got trombones on this, whether or not that outside of the trombones is actually included in the diameter of the outside loop. So if the trombones are actually included in the diameter of the loop, then our diameter would be 4 meters 84 centimeters, and 20% of that is 96 centimeters. So we need to have 96 centimeters. So call it 98 for the connections. So we need 98 centimeters of coax to make our 20% loop. We'll start there, because if it's too big we can always cut it shorter, but if it isn't, well, you know what the problem is. Difficult to make it longer again. Right, we need a meter. Let's measure a meter. So let's start with the end that needs to go back onto the plate. I'm trying to cut this so that you can see what I'm doing. That's proving to be a bit of fun. So this is the bit without any braid. It's just the center core that needs to be connected. Okay, so I'm trying my hardest here to make a nice neat job. Okay, on this end we need to do a nice peel and nice and gently tweeze it up. There we go. So we need to tin and solder both of those, make it nice and neat, and then what we'll do is we'll put some heat shrink on both ends. So those are complete. Okay, I just need to tease this end out. Okay, so that's what we need. So, with the use of a blowtorch, we managed to, I did that off camera because it was just, I needed all my hands. We have welded, quite literally, the inner core of the 96 centimetre length of coax to the driven plate. The centre comes from the centre of the SO239. The earth is also earthed to the driven plate, so in theory we've just got a short circuit. How this works, I don't know, but we'll take it out and plug it in and see what happens. $14.72. So come down a couple more turns, capacitor's out a bit more. So it definitely works, doesn't it? One MagLoop with 14 megahertz, and I expect it will go down to 7 meg as well. So what we've got, okay, we have got a problem with getting enough capacity. So what we're going to do is we're going to make a add-on capacitor that will go on the pipe. And how we're going to do that is by using this pipe clip. We literally clip it on the capacitor, like so. And that's now 100 and whatever that is. So let's put it up and find out. So, I don't know if you can see this, but we've got the 100 puff capacitor strapped across the trombone. And as we come down, trombone is, I'll mark it in a minute on the board. There's the loop, there's our coax cable going up to our MFJ analyzer, and we've got a reading of 1.3, which I could get better if I squish the loop down. Now we're using a shielded loop, a shielded coupling loop, and it's working. Here's a phenomenon I have not seen before, but I think it's because of our Chinesium capacitors. The little blue one I've put on. Watch. So as it charges with RF, it goes out of frequency, and therefore the SWR goes up. And then as it discharges, it will come back in again. Because watch this. Here we go again, you see. So I don't think our little capacitor is the right one for the job. Well, obviously the little blue capacitor doesn't work, so we're going to have to make our own. And why not just duplicate the trombone system? So this is what I'll do. And this is our outside of the capacitor. We are fortunate to have found this 20mm outside diameter plastic pipe, which just so happens to fit perfectly, and I mean perfectly, inside of our 22mm pipe. Now, so we'll solder them on. Okay. Now if we want to make sure that it doesn't rattle at all, we can cut the pipe here, add another one, and then put another one on the bottom. I'm not intending to do that, I'm only intending to use two for this. So one at the top, one at the bottom. Okay, insert it in, and there, believe it or not, is our capacitor. Okay, so what I have done is I have soldered using a blowtorch, quite crudely. I have soldered a, I don't know if that's in focus or not, a piece of wire onto the end of my copper tube. It is quite crude, but it's a good contact. And I've done exactly the same with the inside of the 15mm tube. And I've also soldered the ends on, as you can see. Okay. So the next thing is we now insert our plastic and push it out a little bit on the ends, because we want it to make sure there's no flash over. Okay, so that's I don't know, maybe 1 centimetre on one end, 0.5 centimetre on the other. Okay, both ends are the same. And now I'm going to insert my pipe into it so that it's central. And I'm literally going to put heat shrink on it. And that is our capacitor fixed. Done. Okay, let's test it. Okay, so fully inside with our bit of wire connected up, we have a 100 puff capacitor. which is exactly what I was aiming for. So here's the configuration of the additional capacitor now on the trombone, and that's just basically clipped in, so it can be taken off if you need to use the 20 meter band. Okay, well let's have a look and see if it works. Seven, 1, 2, 5. Just following this through. Okay, that's with our additional capacitor attached. I'm going to have to go and put it on the main transmitter now and see whether or not we have the same phenomena. Okay, I just wanted to show you this. I don't know if you realised, before we had a problem with the Chinesium capacitor. Well, this is with the new trombone capacitor that I've added, and the SWR is very low. Let's see how much the bandwidth is. Okay, usable up to, and okay. So we've got about 80. Turn that off. We've got about 80 kilohertz of bandwidth. Of course, that's only a case of having to go out and retune, or when we get the Arduino working, tune it remotely. Okay, let's see who's on. See if we can make a contact. Roger, Mike 0, Mike Sierra November in the town of Gloucester, UK. Over.
I've got you, Mike 0, Mike Sierra November. Good evening to you, sir. It's a 5-9 issue signal report. Back to you.
Roger, thank you very much indeed. You're also a 5-9. I'm trying out a magnetic loop antennae at the moment, and I was wondering...
OH2 Golf Victor Alpha, good evening. You're 5-9 today. My name's Bob. Calling CQ from Golf Delta 1, November Bravo. Golf Delta 1, Juliet, November Bravo, calling CQ. Calling CQ from Golf Delta 1, Juliet, November Bravo.
Mike 0, Mike Sierra November.
Mike 0, Mike Sugar November. Good afternoon, name here is Peter. Papa Echo Tango Echo Radio, go ahead.
Yes, good afternoon, Peter. The name here is Mike, and you're 5-9 into the town of Gloucester on my magnetic loop, which I've just built today. Back to you.
T1 JMB, Mike 0, Mike Sugar November. Mike, magnetic loop, very interesting. I built one myself about 2 months ago out of copper tubing. I'm just in the process of either manufacturing or purchasing a capacitor. What do you tune yours with, Mike?
I've built trombone capacitor. That's a 15mm pipe inside of the 22mm copper pipe with a bit of insulator, and it seems to be working perfectly well. Over to you.
Which I then sleeve with copper tube on the outside of it. So that seems to work. Give me a rough tune on 40. Not as good as an alpha capacitor. Sugar 57 Delta X-ray, Seeker 20.
Okay, so the MagLoop has been tuned to the 20 meter band, and let's just go off down the band a bit. It's not particularly so we'll see, it might be a bit more around if we turn the preamp on. Okay, let's just quickly go across to AM, and I just want to, with an amazing 10 watts, we'll just see what the SWR is like. Oop, I'll tell you what, let's put it on the MagLoop again, and right, here we go. Well, so it's quite high, it's around 2, and if we go up through the band, it's dropping away to nothing, and then we'll come back up again, but that's fine because that's what we expect it to be. So as you can see, it's all working relatively well, and I'm quite pleased with the results so far. I've still got to put a motor on it to drive the threaded rod I need to, or the threaded bar, I need to put an Arduino so that I can actually control the motor for remote tuning. And there's many things. I might even change the loop for a gamma match. Instead of the bottom loop, I'll put a gamma match on it. And I might even change the capacitors for a shorter capacitors to allow a little bit more upper frequencies, sort of 10 meter band, 10 megahertz. Yeah, 10 meter band, 28 megahertz. So lots to play with, still lots and lots to do, but it's working. So I'm very, very pleased. Thanks so very much for watching. If you'd like what you've seen, please give me a thumbs up, perhaps even subscribe, and call again. Thanks so much indeed. Bye-bye for now.